Welcome students. In this session, we shall learn about the different methods of forecasting population. In the last session, we have studied about the theoretical background of different methods of forecasting population as well as the factors affecting the population growth. Now, I have taken this example as it is given here. So, the for numerical which is given, the data is given, the population of 5 decades from 1930 to 1970 are given below. Find out the population after 1, 2 or 3 decades beyond the last unknown decade by arithmetic increase method. So, these are years from 1930 to 1970 and the corresponding population are given over here. Now, following the arithmetic increase method, now we shall calculate or we shall predict the future population. So, these are years and population. Now, increase in population. How to calculate? That is from 1930 to 1940, within the span of 10 years, the population increase is 28,000 minus 25,000 is equal to 3,000. Similarly, from 1940 to 1950, within the span of 10 years, that is within the span of 1 decade, the population has been increased from 28,000 to 34,000, that is the increase in population is 6,000. In this manner, we have calculated the increase in population for the following decades. Now, the total increase in population has become 22,000 over the period of 40 years, that is 4 decades. Hence, the average increase in population per decade has become 5,500 as you see here. Therefore, the expected population at the end of year 1980 is equal to 47,000. This is the baseline population plus per decade increase is 5,500. Hence, it becomes 552,500. Similarly, the expected population at the end of year 1990 is equal to 52,500 plus 5,500, because 52,500 was the last population in the last decade and 5,500 is the increase in population in 1 decade. That is why the final population or the expected population at the end of year 1990 has become 58,000, or you can calculate in another way also, that is if you consider the 47,000 or that is 1970s population as a baseline population. So, 47,000 plus 2 decades 1970 to 1992 decades, that is per decade increase in population is 5,500 into 2, it gives the same result. Similarly, the expected population at the end of 2000 is equal to 63,500, right. Next, we are proceeding towards the next method, that is geometrical increase method. Year population increase in population, we have already calculated these values in this method, that is arithmetic increase method in the previous method. Now, one column is to be added further, that is percentage increase in population. Percentage increase how much? That is the increase in population is 3,000 over the population of 25,000. That is increase in population is 3,000 divided by 25,000 into 100 is equal to 12%. 1940 to 1950 increase in population was 6,000 over 28,000 initial population. That is why 6,000 divided by 28,000 into 100 is equal to 21.4%. Similarly, 1950 to 1960 population has been increased from 34,000 to 42,000, that is total increase in population is 8,000 over 34,000 initial population. That is why the percentage increase in population has become 23.5%. Similarly, for the next decade it has become 11.9%. Total increase percentage increase in population over the period of 40 years, that is over the period of 4 decades, is equal to 68.8%. Average percentage increase per decade is equal to 68.8 divided by 4 is equal to 17.2%. Therefore, the population at the end of various decades is equal, that is at the end of year 1980 is equal to P within bracket 1 plus I divided by 100 to the power n. We have already discussed about this theoretical background in the last session. So, putting the value or substituting the value in this formula, we will get the expected population, which is 55,080. This n value is 1 because for 1 decade, if you consider with respect to 1970. So, if you consider with respect to 1970, then 1990, this is the period gap is to 20 years, that is 2 decades. So, the n value will be 2. So, in this way we can calculate the expected population. So, in 2000, following the similar method, we can calculate the expected population also at the end of year 2000, which is equal to 76,540. Now, we are proceeding to the next method, that is decreasing rate method. We have already calculated these 4 columns in the previous method, that is geometrical increase method. We have already calculated. So, one column is to be added further beside it, that is decrease in the percentage increase. Please note this, decrease in the percentage increase. So, decrease, that is when there is a decrease, final minus initial, initial minus final. So, initial is 12% and the final is 21.4%. It has become minus 9.4. Remember, here it is minus and this is a decrease, it is also in the negative sense. A double negative makes positive, that is why actually there is no decrease, there is a percentage increase, as you see here. In the similar method, this is initial minus final. Initial is 21.4, my final 23.5. It also gives you the negative value, that is minus 2.1, that is negative value, that is negative decrease in the percentage increase. What does it mean? It means there is the increase in population. If you compare the population growth of this span, that is this decade, that is the 23.5%, and the population growth considering 1960s and 1970s population, that is within this span, within this decade, the population growth was 11.9%, that is there is the decrease. Initial minus final 23.5 minus 11.9, that is plus 11.6, that is there is the decrease in the percentage increase, positive decrease, that is positive decrease means actually there is a decrease, what it is reflected over here. In this way we can calculate the average increase in population per decade, as we have already calculated in other two methods. Now, the decrease in the percentage increase, if you add all these values, so it gives the total value 0.1%. So, the average decrease in the percentage increase is equal to 0.1 divided by 3, that is 3 data are there. So, is equal to 0.03%. Therefore, the population at the end of various decades, 1980, if you the baseline population, 1970s population is considered 47,000 plus 11.9 minus 0.03, 11.9, that is the this was the last decade's increase in population, percentage increase in population, and the decrease in population is 0.03. that is why decrease is 11.9 minus 0.03, which is equal to 11.87, and the initial population, that is the population what we consider as baseline population, 47,000. So, it is the total value gives the expected population at the end of year 1980, which is 52,570. So, if you consider the 1980s population as a baseline population, so you can calculate the 1990s population with respect to 1980s population. So, 1990s population is 52,570 plus 11.87 was the last year's increase in percentage increase in population, and 0.03 is further there is a decrease. So, 11.87 minus 0.03 into 52,570. So, ultimately after calculating all these things, so you will get the final value 58,800. Similarly, at the end of year 2000, you can calculate the expected population at the end of year 2000. Next, incremental increase method. Incremental increase method, if you see, this is the data given. Increase in population we have already calculated earlier. Now, the incremental increase. Incremental increase, this is, that is the, for this decade the increase in population is 3000, for this decade increase in population is 6000. That is, if you compare these two decades, then there is the increase in the population, that is from 3000 to 6000. So, how much there is the increase? There is the increase is 3000 plus 3000. Then from 6000 to 8000, increase is 2000. So, in this manner, if you calculate the increase in population from that is for this decade is 8000 and for this decade is 5000. So, increase in population is minus 3000, actually there is no increase, there is the decrease in the population. If you sum up all these values, so the average increase in population is 22,000 divided by 4 is equal to 5,500, and the average incremental increase is 200 divided by, this is these are the three data, that is why average is 2000 divided by 3 is equal to 667. Hence, the population at the end of various decades. So, 1980, we are considering the 1970s population as the baseline population. So, with respect to 1970s population, we can calculate 47,000 plus 5,500 is the increase in population, and there is the incremental increase is 667. So, 5,500 plus 667. So, here actually two increase, that is one is the increase in population and another is the incremental increase, these are to be added. So, if you go back to the formula incremental increase, that is you can see the P n is equal to P naught plus n into I A plus I C. I is the average arithmetical increase and this is the average incremental increase. I have already given this formula in the last session. So, in this way we can calculate the population or the expected population at the end of each year. Next is the simple graphical method. Simple graphical method, that is from 1930 to 1970, the data, it is the, this data have been given. So, from this given data I have plotted this curve up to this point. Now, we have to extrapolate the curve following this path. So, the nature of the curve remains same. So, we can extrapolate in this manner also. One can extrapolate this data following this path B and another person can extrapolate the data following the path C. So, A, B, C, these are the 3 person can predict in 3 different ways of the future population in 1980, 1990 and 2000. That is for 2000 for person A, this will be the expected population, for person B this will be the expected population, and for person C this will be the expected population. So, as I have already told you in the last session that the extrapolation depends on the intelligence of the designer, experience depends on the experience, intelligence and the background knowledge. So, this will not give you the accurate result, it is just the approximation. So, simple graphical curve method is approximate method, and the next is the comparative graphical method. Comparative graphical method, in this method we have to choose the curve of the cities which is quite similar to the city which is under consideration or which is being studied. So, from the existing data I have plotted the curve from 1930 to 1970. Then the cities whose characteristics are matching with the existing city. So, that is we have found 4 cities whose characteristics or the nature of development, geographical situation, etc., so are matching with the existing city X. So, we have plotted this curve for city A, city B, city C and city D. Now, which path to be followed? It is better to follow the intermediate path. So, that is why the dotted line has been plotted for city X, and from the plotted curve we can interpolate the data. It is the extrapolation because it has been extended. So, from the extrapolated curve we can predict the future population with respect to different years. Here I have just shown 2000 year 2000, and this will be the population. So, I think you have understood the different methods of population forecasting, and thank you for watching this video. Wish you all the best.